Section B of the Unity version 2 test, and all of them actually, is really the heart of the whole test, and it took the most time in class because students are learning to add and subtract fractions, including when they are both mixed numerals, and it takes a lot of work. So it could be that your student needs more practice than just these 6 problems. I'm going to show how to solve these sort of like a search and destroy method that we talked about earlier in the year. I'm just going to kind of do the same step all the way through as much as I can, and that could be a good way for your student to practice. Then they have to be ready to think that I have to complete each one of those in that problem. Or again, they might do that step, the first step all the way across, second step all the way across, or whatever it is. In general, these are like the 4 big things that we taught about how to solve problems like this. The first question you're always answering is making common denominators. Then students need to be careful to recopy their work in layers, and you'd be surprised how many errors people make because they forget these whole numbers when they're working through them. So recopying in neat layers is very important. The question of borrowing and how to borrow and so forth was a big subject in class. Reducing to make a final answer. You can do everything correct in the first 3 steps, but if you don't reduce to the final answer, you only get 1 out of the 2 points that each one of these is worth. So that's important. Reducing fractions. We've spent a lot of time looking for even numbers. If there's an even number numerator and denominator, you can always cut them in half, and you just keep cutting them in half as long as they're both even. You also look for prime numerators. If you have a prime numerator, there's a good chance that the fraction is reduced. And then, of course, the main thing is you're always looking to see if the numerator can go into the denominator. Or if you flip that around, is the denominator a multiple of the numerator, like 7/21, because the 7 would go into the 21. So I'm going to try to show all of these steps over and over again. It could be important that you even ask your student to stop the video now and see if they can repeat writing these notes, the top 4 things there. Okay, so showing the first step is making common denominators. I'll zoom in here, and again, I'm going to make common denominators in all of these. The first thing students need to remember is that if one denominator can become the other one, then don't cross multiply. Cross multiply is when you say 4 times 8 makes 32, and so 32 would be a common denominator. And you can do that, but then you're going to have to reduce more steps. So when I do this, I'm always going to be saying if one of these numbers can simply turn into the other one, I'm only changing one of the fractions like this. 2/4. The 4 can become an 8, and then I'd be adding 2 8s like this. And if I do that, I'm just going to keep it 2 8s, and if I doubled the 4 to make 8, I'm going to double the numerator, so that's 4, and now I'm going, put my equal sign, I'm going to my next fraction. The next one, of course, is I'm still trying to find common denominators. Here I've got 3 and 5, and because they don't go into one another, the common denominator is going to be 15 by multiplying them. 5 times 3 is 15. Make sure you get the subtraction symbol in there, and then we're going to move to the next one because we're just looking at making common denominators. When you have a mixed numeral, you ignore the mixed numeral or the whole number for a second. Look at the 2 and 3. 6 is the common denominator there because 2 times 3 is 6. So you might want to go 5 minus 2 like this to make sure you're getting minus. A lot of students put a plus in some of these problems. You need to be careful to avoid that sort of error. It's about precision. Number 9. In number 9 here, again, the 9 can turn into an 18, so I can make 18 plus 3 in the 18 like this, and I can move on to my next one. Number 10. The 5 can certainly turn into a 20, so I simply write a 20 minus 4 20ths over here. A lot of students forgot this 5 and 4 on this problem like that, and that would be a way to fail it right at the beginning. And the last one here, 5 and 8, they both go into 40 because they cross multiply them, so it's going to be over 40. This is 1 and something 40ths plus 7 and something 40ths. And now that's the first step all the way done. Going back, the next thing you do is you recopy in layers. Well, we've been working on that. We're going to go ahead and put the top on it because that's part of the layer. So in this case, I just doubled to make that 4. Over here, I actually had the cross multiplication going on, and I'll draw a little picture to remind what cross multiplication is. Cross multiplication means you've multiplied these two against each other, but then you also multiply this up and this way. The arrows are real important because 3 times 1 is not 3 on this side, it's 3 times 1 straight direction, it's on this side. 5 times 2 is straight direction, it's on this side. So the 10 would be up there and the 3 would be there. That might be mental work that I'm doing. This side would be 10 over here, and this would be 9 over here. And that one, whoa, that's a 3, sorry. So 10, and I'm ready to go, I can actually finish my subtraction. But for the sake of talking just about the steps, I'm going to show number 8. On the 8 here, my whole numbers are the same. It's 3 times 1 is 3 up there, and 2 times 2 is 4. I finished that layer. It's recopied. Number 9. Number 9, I don't do anything to this side because it's already 18ths. I'm just going to copy the 5 down. But I doubled that 9 to make 18, so I double the 4 and make that 8. Next one, I've got 20ths. This side's 20, so I leave it alone. I just bring my 3 down. This time I multiplied the 5 by 4 to make 20, so I multiply the 2 by 4 and get 8. Last one. Last one I made it is a cross multiplication, so I made 40, and then 8 times 4 is going to be 32 on this side, and 5 times 7 is going to be 35 on that side. Okay, my next step is to see if I can complete the equation and if I need to borrow. It could be that some of these are done in their next step, and some of them might not be. So this right here just adds straight. It's got a common denominator. It's 6/8. I'm not going to circle my answer yet because I'm going to talk about reducing that, because 6/8 does reduce. This one here, 10 minus 3 is 7/15, and 7 is a prime number. Only 1 and 7 can multiply to make 7, and neither 7 cannot go into 15, and since 1 is the only number that goes into 15, 1 is the only thing that 7 and 15 both share. That's why it's a reduced fraction. This one here, I cannot take 4 from 3. So this is the first one where I'm going to have to work at borrowing. Now I'm going to show one way of doing this. There are other ways, but this is the way I showed in class. If I have 5 wholes and 3/6 minus 2 wholes and 4/6, I need to borrow just like I would